plus 3y's. We have 0 z's, so you either can write 0 z's or you can just leave it blank and just say that equals 5. Either way is fine. Either write 0 z's or you don't write anything there. Our next one has 0 x's. It has 1 y, so I'm just going to put a y down. It has negative 4z, so we have minus 4z, and that's going to equal 8. And finally, we have negative 2x, 0 y's, and 5z's, so plus 5z equals 7. So that's what both of yours should look like. Questions on that? All right, then questions from the homework. Grace. Which one? 24. Ooh, I was just going to sign. All right, 24 gives us a system of equations. Negative x plus y equals 2. So what I first have to do is write it as an augmented matrix. I came up with the augmented matrix negative 1, 1, 2, negative 3, 1, negative 2. Do we have the same augmented matrix? All right, the first thing I'm going to do is I'm going to go from left to right, and I'm going to locate the one that needs to be a positive 1. That is that negative 1 here. To make that a positive 1, I need to multiply it by a negative 1. So I'm just going to multiply everything in row 1 by a negative 1. So negative 1 times row 1, kind of like that, is going to become my new row 1. Well, that's going to give me the matrix negative 1 times a negative 1 is a positive 1. Negative 1 times a positive 1 is a negative 1. And 2 times a negative 1 is a negative 2. I didn't do anything to row 2 yet. All right, now I have to locate, I already have 1 is the 1. Now I have to locate the one that needs to be a 0. That is that negative 3 needs to be a 0. Now I need to use the 1 right above it to turn it into a 0. So I need to multiply this 1 by 3, which added to that negative 3 would make it 0. So I'm going to multiply all of row 1 by 3 and add it to row 2, and it's going to become my new row 2. So we're going to write that just as I said it. We'll go 3 times row 1 plus row 2 is going to become my new row 2. Well, I circled something down here, so this should change, but my top row will not change. So my top row will remain that 1, negative 1, 2, or negative 2, over, and now we're going to do that math. So we do 3 times 1 plus negative 3. So 3 times 1 is 3, plus negative 3 is 0. Then we go 3 times negative 1 is negative 3, plus 1 is a negative 2. Then we do 3 times a negative 2 is a negative 6, plus negative 2 is going to be a negative 8. Now I'm done with that first column. We move to the next column and we locate our 1 first. Our 1 needs to be where that negative 2 is. So that means I'm going to multiply that entire row 2 by its reciprocal, and I need to multiply it by negative because I want it to be a positive 1. So I'm going to go, well, multiply that row 2 by negative 1/2 times row 2 becomes my new row 2. That means I'm just multiplying that entire row by negative 1/2. It means I'm not doing anything to row 1. So row 1 will remain 1, negative 1, negative 2. Multiply all of row 2 by negative 1/2. 0 times negative 1/2 is still 0. Negative 2 times a negative 1/2 is a positive 1. And a negative 8 times a negative 1/2 becomes 4. All right, the last thing I need to do is I need to make everything else in that column 0. So I need to turn that negative 1 into 0. In order to do that, I really just have to add row 2 to row 1, because that will already make it 0. So that's all I have to do is row 2 plus row 1 is going to become my new row 1. Well, if we follow this, 0 plus 1 is still 1. So that's stuck there. 1 minus 1 is 0. And then 4 plus negative 2 is 2. 0, 1, 4. That means we have x equals 2 and y equals 4. Do all those steps make sense? All right, other questions? Yeah, Leo.
The last one.
The last one, 25. All right, let me just take a picture of that one because we're going to go over a big one today and a couple others. All right, so the first thing you needed to do is you needed to create an augmented matrix. And I came up with 1, 5, 7, -2, -7, -5. Now, your first step after your augmented matrix is to put a 1 in this top left. Well, that's already done for you. You don't have to do any more work. It's already a 1. So that means you move on to the next step and you make everything else in that column 0. So that means this -2 needs to be 0. In order to do that, I'm going to multiply row 1 by 2 because 2 times 1 is 2 plus -2 would give me 0. So that's what I did. And then we have 2 times 5 would equal 10 minus 7 equals this 3. And then 2 times that 7 is 14 minus 5 gives me that 9. And now I have my 1, 0. Now we have to go back to step 2 or step 1 where you have to find that column which needs to be 1. Well, that 3 needs to become a 1. And the easy way to do that is just multiply that entire row by 1/3. All right, so when I distribute 1/3, 1/3 times 0 is 0. 3 times 1/3 is 1. 1/3 times 9 is 3. Then all I have to do is change this 5 to a 0. To do that, I need to multiply that 1 by -5 and add it, which would be 0. So I'm going to multiply this entire row by -5. I guess I didn't write the whole thing here. I kind of shortcutted it. I should actually have down here -5 row 2 plus row 1 becomes row 1. That'd be a better way to put it. So -5 times row 2, -5 times 0 plus 1 is still 1. -5 times a 1 is -5, plus 5 is 0. And finally, -5 times that 3 is -15, plus 7 gives me a -8. Good?
Yeah.
Okay, awesome. All right, any other quick questions? Okay, then we'll go on to a much bigger problem. This is 3 variables. This is 3 variables, but the process is exactly the same. It's just a lot more numbers that you can screw up, which is always fun. So this one we have 2x plus 2y plus 2z equals 7. We have 4x plus 6y plus 14z equals 0. We have x plus 3y minus 2z equals 17. Whenever I tell you to use Gauss-Jordan elimination, you need to put it in an augmented matrix. So your augmented matrix should look like this. We have 2, 2, 2, 6. And the next one we have 4 x's, we have 6 y's, we have 14 z's, and we have 0 as our constant. And our bottom one we have 1, 3, -2, and 17. So that should be your augmented matrix you started off with, but we should all be okay writing that. I'm going to jump to my next slide, and hopefully I have those values in there. I do. Do those look right? Those are the same ones we had. Okay. Okay. Method is the exact same. We work left to right. We locate our 1 first and make it 1. And we make everything else in that column 0. So everything is the exact same. So just remember, your identity matrix, I'm not going to off to the side. Our identity matrix would look like 1, 1, 1, 0, 0, 0, 0, 0, 0. That's what I want this to look like. So I'm going to locate what needs to be 1 in our very left column. That is that 2. That 2 needs to be a 1. Well, making something a 1 is pretty easy. There's actually 2 methods in this one. I'm going to do the one I did in my notes so every class sees it, but I'll tell you another way to make that into a 1. So the easy way is just multiply it by its reciprocal. So I'm going to multiply everything in row 1 by 1/2 and replace row 1 with those values. So 2 times 1/2 is 1. Ooh, that's what we wanted. 2 times 1/2 is still 1. 2 times 1/2 is still 1. 6 times 1/2 is 3. I didn't change anything else, so row 2 is going to stay the same. And row 3 is the same. Let's look back at this one. I haven't showed you this method, but does anyone take a guess at how I could turn that top value into a 1 without multiplying 1/2? Rena.
You could subtract the top with the bottom row.
Absolutely. What else could we do? There's actually one more. I didn't think of that one. That one works. Yeah, Brody. Just flip them, too. So Rena said we could go, well, we could say, okay, row 2 plus row 1, replace that value with row 1. So we'd have 2 minus 1, it gives you a 1. 2 minus 3 would be -1, so on. And Brody said we can just flip them, too. Those are all you have to do is put a 1 up here. And if you can use something down below, you can do that. All right, my next thing is I need to make everything else in that column 0. So we really are going to do 2 steps in one. I'm going to turn that 4 into a 0. And I'm going to turn that 1 into a 0 all in one step. All right, let's focus on the 4 first. They're all going to go back to this 1 I just created. I'm asking myself, 1 times what plus 4 is going to give me 0? Well, that's just multiplying by a -4. So this always follows the same thing. And this is a 4, I'm going to multiply by -4. If this was a 5, I'd multiply by -5. If this was a 6, I'd multiply by -6. So since it's a 4, we're going to multiply by -4. And we're going to multiply row 1 by that -4. So whatever row I created the 1 in is the one I'm going to multiply that value by. Then we're going to add that to row 2. And that's going to become my new row 2. Well, row 1 is going to stay the same. I didn't circle anything in row 1, so row 1 is going to stay the same. So we're still going to have 1, 1, 1, 3. Row 2 is going to change. I'm going to go -4 times 1 plus 4 equals 0. Then I'm going to do -4 times 1 plus 6. So I have -4 plus 6 is going to equal 2. Then I have -4 times 1 is a -4 plus 14 is 10. And that final thing would be -4 times that 3 that's in the top right would be -12. And add that to 0 and we still have -12. All right, to get rid of that 1, I'm just going to multiply by a -1. It's its opposite. So I have -1 times row 1 plus row 3 this time, because I'm in row 3, becomes my new row 3. Logic stays the same. -1 times 1 is -1, plus that 1 gives me my 0. -1 times 1 is -1, plus 3 is 2. -1 times 1 is -1, minus 2 is -3. And finally, -1 times -3 is, -1 times 3 is a -3, plus 17 is going to be 14. Someone want to tell me what I have to do next? What is my next step? I'm done with that column. I need to move to the next column. What am I trying to do in the next column? Fritz.
Make the 2 in the middle of 1.
Make the 2 in the middle of 1. Yeah, we just had to figure out which one needs to be 1 and make it 1. So we need to make this 2 a 1. And how am I going to make that 2 a 1? What's an easy way to make that 2 a 1? Rena? Divide the row by 1. I would say, because we usually use multiply by 1/2. Yeah. So we're going to multiply that entire row by 1/2. So we'll say 1/2 row 2 is going to become my new row 2. I'm not doing anything to row 1. So that's going to remain 1, 1, 1, 3. Row 2, everything's being multiplied by 1/2. So that's 0 times 1/2, which is still 0. 2 times 1/2 is 1. which is awesome. 5 times 1/2 is 5, or 10 times 1/2 is 5. Negative 12 times 1/2 is a negative 6. Row 3 stays the same as 0, 2, negative 3, 14. As soon as I have that 1 in the proper place in my column, I need to change everything else to 0. So this 1 needs to become a 0. This 2 needs to become a 0 as well. We use this 1 to get rid of it. And all you do is you think to yourself, 1 times what plus 1 gives me 0? Well, that's going to be a negative 1. So we're going to go negative 1 times row 2 plus row 1 becomes my new row 1. Negative 1 times 0 plus 1 is still 1. That should always remain the same. Then we have negative 1 times 1 is negative 1. Plus 1 is 0. Negative 1 times 5 is negative 5. Plus 1 is a negative 4. And then we finally have negative 1 times negative 6 is a positive 6. Plus 3 is going to be a positive 9. Row 2 is going to stay the same. I didn't circle anything in it, so it's going to stay the same. Row 3, we need to get rid of this 2. If I need to get rid of this 2, what am I going to multiply row 2 by to get rid of it? Yeah, Liv. By negative 2. So we're going to multiply row 2 by negative 2. Negative 2 times row 2 plus row 3 is going to become my new row 3. So negative 2 times 0 is 0, plus 0 is still 0. If that ever changes, you made a mistake. Negative 2 times a 1 is negative 2, plus 2 is 0, which is what we wanted. Negative 2 times that 5 is negative 10. Minus 3 is a negative 13. And then finally we have negative 2 times negative 6, which is a positive 12, plus 14 is going to be 26. What I want you to do right now, either by yourself or in your pods, finish this. You just have one more column to do following the exact same steps. Locate your 1. Turn it into a 1. That will be this step. And then your last step will be turning those other 2 into zeros. So I want you either by yourself or in your pods. It's easier if you have someone helping you. To go through this, we're going to run out of time otherwise. So my first step here is to circle what needs to become a 1. That negative 13 there needs to be a 1. The way to do that is to multiply by its reciprocal. And not just that, it has to be a positive 1, so I'm going to multiply by negative 1 over 13. And since that's row 3, I'm going to go negative 1 over 13 times row 3 is going to become my new row 3. So I'm now going to have 1, 0, negative 4, 9, of 0, 1, 5, negative 6. And I will have 0, 0, negative 1 over 13 times a negative 13 is just 1. And then 26 times negative 1 over 13 is actually going to be a negative 2. So right now, I know for a fact this is x, y, z. Z equals negative 2. So I'm 1/3 there. Now my next thing is the rest of these need to be zeros. So let's look at that negative 4. Let's look at that negative 4 that's up there. Right now, if I added row 3 to row 1, I would have negative 3. I don't want that. I want, when I add row 3 to row 1, I want it to be 0. To do that, I'm going to multiply row 3 by 4. 4 times row 3 plus row 1 is going to be my new row 1. Because when I do 4 times 1, it becomes 4, plus a negative 4 will become 0. So let's go ahead and do all of that work. So we have 4 times 0 plus 1 is still 1. 4 times 0 is 0 plus 0 is still 0, so it should still remain 1, 0 up here. 4 times 1 is 4. Minus 4 is 0. And finally, 4 times negative 2 is a negative 8. Plus 9 is 1. And now we're going to do the exact same thing for that 5. I'm going to multiply row 3 by negative 5 times row 3 plus row 2 is going to become my new row 2. The 0 and the 1 will remain 0, 1. Negative 5 times 1 is negative 5, plus 5 is 0, so that's good. And then we have negative 5 times a negative 2 is a positive 10. Minus 6 is 4. And then finally we have 0, 0, 1, negative 2. So we have x equals 1, y equals 4, and z equals a negative 2. Questions on that? Okay, we have like 15 minutes. We should be able to get through all this stuff. We're just going to go through some special cases. So we'll have some more examples to do. First of all, dependent systems. Those are the ones with infinite solutions. So we start off with 2x plus y equals 4 and 4x plus 2y equals 8. So we are going to solve this equation using Gaussian elimination. So that means I need to write an augmented matrix. So that means we're going to have 2, 1, 4, 4, 2, 8. Gaussian elimination says that we need to turn it into the identity, which means this 2 needs to become a 1. So I'm going to circle that 2. The easiest way to change a number into 1 is just multiply by its reciprocal. So I'm going to multiply all of row 1 by 1 over 2, and that's going to become my new row 1. My new matrix is going to be 1, and then 1 times 1/2 is 1/2. 4 times 1/2 is 2. Row 2 is going to stay the same, so it'll be 4, 2, 8. As soon as I have a 1 in a column, I make everything else 0. So that means that 4 right below it needs to become a 0. Since it's a 4, I'm going to multiply something by a negative 4. We'll have negative 4 times row 1 plus row 2 is going to become my new row 2. Once again, because I'm using that 1 to get rid of this positive 4. So our new matrix is going to look like 1, 1/2, 2. And now what we're going to do is we're going to do that negative 4 times row 1. So negative 4 times 1 is negative 4, plus 4 is 0. Negative 4 times 1/2 is a negative 2, plus a negative 2 is 0. Negative 4 times 2 is negative 8. Negative 8 plus 8 is 0. That's different. It's different because now if I tell you to turn this into 1, you can't. Because you can't multiply this by 1 over 0 and it becomes 1. What's happening right here is a special case. If we look right there, what we have currently is the equation 0x plus 0y equals 0. In other words, you have 0 equals 0. So this is a case when you use elimination or substitution where your variables disappear. So you have to ask yourself, is that a true statement or is it a false statement? Now 0 does not always equal 0. It's weird. But in these cases, 0 equals 0 is a true statement. So that is true That says tray. That is true. So it's a dependent system. There are infinite solutions to that system. So that's the first case of looking for a dependent system. Our next case doesn't happen very often and is in fact, I already know by looking at that second system, it is most likely dependent. And that is because we have 3 variables with 2 equations. You can't solve 3 equations or 3 variables with 2 equations. To solve 3 variables, you have to have 3 equations. And we'll look at what happens if I try to solve this using Gaussian elimination. So we're going to write it the exact same way. We'll do an augmented matrix where we have 1, -1, 1, and 2. And on the bottom one we have -2 x's, 1 y, 2 z's, and 5 is our constant. You can kind of already see the problem with this. In order for me to get the identity, I would need to have 1's running all the way down. We're not going to be able to make that happen. We can try, but we can already picture that I can't put a 1 down here. There's no room to put a 1 down here. So what really exists is a column that says 0, 0, 0, 0, or a row that says 0, 0, 0, 0. So starting off, I already know it's dependent. Just because of the fact that to make this true, I would have to have a 0, 0, 0, 0. Now, if you don't catch that, which several of you might not, we're going to go through the steps of solving it and seeing what it looks like at the end. So just remember, what we really have, this is kind of an option down below. What we really have is 1, -1, 1, 2. We have a -2, a 1, a 2, a 5. And that last row would be 0, 0, 0, 0. That automatically makes it dependent. That automatically makes it dependent. Now, if I try to solve it using Gaussian elimination, though, my first step would be to make this first one 1, which it already is. So this is the quick step. This is done. This is 100% done. You can do this step. But let's say you miss that, and you go through and you solve it. So the first thing I would do is locate my 1. It's already there. Make everything else in that row 0, which means I would do row 1 times 2 plus row 2 becomes my new row 2. Well, that's going to give me 1, -1, 1, 2 up here. Down below we have 2 times 1 is 2 plus 2 is 0. 2 times -1 is -2. Plus 1 is going to be a -1. 2 times 1 is 2 plus 2 is 4. 2 times 2 is 4 plus 5 is 9. Now I'd go to the next column, figure out what needs to be 1. This one right here should be a positive 1. So we'll do a -1 times row 2 becomes my new row 2. Row 1 remains. 1, -1, 1, 2. And down below we're going to have 0. -1 times -1 times a -1 is a positive 1. Times 4 times a -1 is a -4. And finally we have -9. Now I just need to make this one a 0. Well, I just have to take row 2 and add it to row 1. Row 2 plus row 1 becomes my new row 1. Let's see if I can squeak this in there. It's going to be tiny. We're going to have 1, 0. Negative 4 plus 1 is negative 3. And then negative 9 plus 2 is a negative 7. And down here we have 0, 1, negative 4, negative 9. I don't have the identity. The furthest I can get is basically, that is x minus 3z equals negative 7. And this one is y minus 4z equals negative 9. What that means is z can be any value. Because x and y are depending on what z is, and z can be any value. You can pick a 2 and a 2 for this, and you can solve for your x and y. You can pick a 3 and a 3 for this, and you can pick an x and a y. So z can be anything in this system. So that's why it's dependent. So both of these lead to the fact that it is dependent. This way, because we know it's true, 0 equals 0. This one, because z can be any value, there's no way to solve for z. All right, the last thing we're going to talk about is inconsistent systems. Now, inconsistent systems are ones where the variable drops out, but you have a false statement. So we should be able to see that as we solve this one. Well, before I start solving this, I want to make sure the variables are all on the left-hand side. So I'm going to rewrite that top one is x minus y equals 3. And that bottom equation, I'm going to have negative 2x plus 2y equals 5. So you need everything on the left-hand side, and your variables must line up to put it into an augmented matrix. All right, now we're going to go ahead and put it in an augmented matrix, where I have 1, negative 1, 3. And that bottom one is going to be negative 2, 2, and 5. With Gaussian elimination, we go from column to column. We start with the left-hand column, and we ask ourselves, where does a 1 need to be? A 1 needs to be there. Check. It's already there. I don't do any work, because it doesn't pay to multiply this whole thing by 1 and leave it all the same. So we already have our 1, which means I go to the next step, which says locate what needs to be 0. Well, this negative 2 needs to be 0. So that means I'm going to multiply this 1 by a positive 2, so I can have 2 times a negative 2 being a 0. So we're going to do 2 times row 1 plus row 2 is going to become my new row 2. All right, 2 times 1 is 2, minus 2 is 0. 2 times a negative 1 is negative 2, plus 2 is 0. And then finally we have 2 times 3 is 6, plus 5 is 11. Our top row never changed. It's still 1, negative 1, 3. I am done with this problem. I am done with this problem because this is also a special case, because I can't turn that 0 into a 1. And remember, what that equation is actually saying is if you have 0 x's and you add 0 y's to that, it's going to equal 11. In other words, 0 equals 11. That is false, so it's inconsistent. All right, any questions on anything we covered today? I'm really stressing the importance that you take your time on this homework and you understand how to do all of those problems. Because tomorrow we're going to use our calculator, and then we move on to a different method using matrices. So this is kind of like your big attempt to understand how to use Gaussian elimination. So if you're still struggling with it, come to me and get help. The more you practice these, the more you actually try to understand it, the easier they become. If you don't know what's going on and you're just guessing your way through the homework and you're just using the answer guide, you're going to get a bunch of problems wrong on the test. All right, so make sure you understand what's going on. Try your best. Try not to just use the answer key to solve the problems. And have a wonderful day.